Yeah, so thanks everyone. It's great to be here. I really appreciate having the opportunity to share some of my work with you today. So this is a project I've been working on for a while, kind of on and off. It's a little bit outside of my main research stream, and so because of that, it's been one of those things that's kind of easy to hit the back burner. But I'm hoping I can use this presentation to kind of motivate myself to finally just finish revising this and get it out the door. And I'm also really excited because I think it'll dovetail really nicely in a whole lot of ways with the presentations that we've already heard today. So the broad question that I'm interested in is the following, which is why is fragmentation so common in many knowledge communities? So by fragmentation, I just mean that there's a lack of connections among subgroups within some kind of community. And then by knowledge community, I'm using that term and thinking about them, at least from a conceptual point of view, pretty broadly. So any kind of community that's organized around creating or applying some kind of specialized knowledge. So a couple examples of fragmentation in knowledge communities are, one is academia and scientific fields. So we're always hearing these calls for greater interdisciplinary work. And I think this conference has been a really cool example of seeing people from lots of different backgrounds, but all the time I know, Minnesota, the provost is always trying to create these incentive programs to get people to collaborate with individuals in different schools, and so it sort of suggests that there's fragmentation. Same thing. So I'm coming from a business school, and all the time we hear about silos in companies, especially around things like R&D, and we hear cases where a company had all of the right people kind of working and doing the right sorts of things, and if they had just been able to find each other and get together, they could have made the next big breakthrough, right? But instead the company started falling on hard times and got kind of eaten up by its competitors. And then in healthcare too, so healthcare today has been, and healthcare reform has been in the news quite a bit today, but for a long time, the past certainly 8 years, but even longer, there's been a lot of attention to fragmentation in the healthcare community and concerns that primary care providers, specialty care providers, surgical care providers aren't talking as much as we might like to see them and talk with one another, and that can leave patients falling through the cracks and create other problems, add to costs and hurt quality and so on. So what's kind of surprising about that and the amount of fragmentation, or at least these perennial calls for better integration that we hear, is that we also know there are a lot of benefits to bridging and connecting across disconnected subgroups in a network. And this has been a real highlight of work in network analysis, stuff on brokerage, and work on bridging in studies of science, looking at how, for example, scientists who bridge across different domains can write papers that are higher impact. R&D scientists who collaborate with people from different parts of the organizations often create more innovative products and things like that. And so then the question is, why don't we see more, given these incentives for bridging, why do we continue to see so much fragmentation? Wouldn't that end up closing if people were bridging as much as we might think that they are? And so this isn't, I don't think this is, as far as I know, it hasn't been a really focus of research. Why do we see so much fragmentation? But we can call a couple different kinds of examples from existing work. So one thing you might think about is that maybe there are personality factors, right? So maybe some people have a certain kind of personality that makes them more comfortable bridging across different groups, and maybe that personality trait is a rare personality trait, and so there just aren't that many people who want to be in a bridging sort of role. There could also be issues dealing with costs and benefits. So maybe it's just not worth reaching outside of your area and trying to, say, collaborate with someone in a different place, because the incentives just aren't there, and the benefits that you might get aren't worth the extra effort that it takes to work with someone far away. And then there could be preferences too. So we know from lots and lots of research that people prefer to interact with other individuals who are similar to themselves, and that could be in their training background, the kind of knowledge they have, and other sorts of things. And so maybe they're just issues of preferences that prevent people from bridging. So those, I think, are all plausible explanations, and surely they contribute in some ways to the answer, but they all at least leave something to be desired as well, is what I want to argue. So personality, for example. One of the biggest personality traits that people talk about as being associated with bridging is high self-monitoring, right? So people who are really attentive to their behavior and adjust it to the social situation that they're in. But if you look at the work in high self-monitoring and you try to, and you look at the surveys that they've run and the distribution of high self-monitors, oftentimes they report upwards of 50% of the sample is high self-monitors. And so it doesn't seem that there's a real huge, big shortage of people who have the personality that would push them to bridge. Same thing with the costs and benefits. So I gave the example of companies that seem to have all the right pieces there, but people just didn't connect, right? And so surely in those cases, there are definitely incentives to actually connect across boundaries. But we still don't see it happening. And we also see cases like maybe what I'm going to talk about, online communities, where really the costs are pretty low and the benefits could be quite high to connecting across a group, and it still doesn't happen. And then preferences, again, surely probably plays part of a role in the answer, but we still see people not bridging and connecting just with people in their own subgroups, even in settings like networking events where they say that they want to connect with different sorts of people and meet new kinds of people. So what I'm going to do then is suggest that rather than focusing on individual differences and issues of incentives, we should start to think about the context, right? Differences in networks, and in particular, whether some networks and some communities, some knowledge communities might be more searchable than others, and push people to reach outside or make it easier for people to reach outside their area and connect with different people, and then close these gaps. So this is just to, before I move on, make sure we're all on the same page with what I mean exactly by fragmentation and the connection to bridging. And so you can think of this as just a simple knowledge community, right? A very small group of people. And ignore for now the red edges, and the dots are people, and the black edges are some kind of exchange knowledge sharing relationship. And you can see that this network, this community has some properties. It's pretty fragmented, right? If you got rid of this node, you'd have 3 communities that just sort of would fall apart and be essentially completely isolated from one another, right? So it would be a fragmented community. But if we added just a couple additional exchanges, if these people started exchanging information and those people started exchanging information, in some regular basis, then you could say that community was more integrated, less fragmented, right? So that's the connection between fragmentation and bridging. So what I want to talk about, I mentioned search, and I think that search could play a really important role in understanding why we see high levels of fragmentation or higher levels of integration conversely. And for people to bridge outside their areas, what I want to suggest is that they need to be able to search inside their communities to find other people. And that's a big problem, these search barriers. One way that knowledge communities often help, or some tools that are often available to people in knowledge communities to try to find people in distant parts of their networks, are knowledge categories. Right? So sometimes these are more deliberately created, sometimes they're kind of an emergent thing that aren't necessarily created for purposes of search, but are created for other types of purposes. But the way that I'm thinking about knowledge categories is as some kind of formal map of a community's accumulated knowledge, right? So think of like library categorization systems, journal keywords, things like that. So a couple more specific examples from the literature would be things like there's been a lot of work on knowledge repositories and consulting firms and other kinds of business where people use databases and categorize questions and old project materials by practice groups or industries or things like that. In R&D firms, kind of a classic example would be directories of people where individuals are categorized by questions or topic areas that they know something about, and you can use those to find people that might know something on your particular topic. And what I'm going to focus on most of all, and is pretty widely used today, kind of more and more what we think about when we think about knowledge categories, are probably tagging systems, right? So collaborative tagging on electronic websites, online communities. So I'll talk a lot about this when I start to get to my data, but just as a preview, these are 2 examples of tags from websites, online communities in my data. This is for a server administration website, and so tags for Linux, networking are prominent tags that categorize certain types of questions and kind of indicate what a set of prior knowledge might be about and a set of users might be interested in. So how would the categories help with search? Well, one of the things you can start to think about, first of all, is your typical search process, right? So imagine you've got a question, and I mean, your first step might be to just do a quick search online, right? But imagine something a little more of a challenge, something that's a little outside your area, and you might not know even the keywords to search you want to search for, right? So you don't even know what you're going to type into the search box. So you might start asking some of your colleagues, people down the hallway from you, to see if they know anything. And then if they don't know, maybe they'll help you out and they'll try to find some people that they know that they could make you refer you to. And this kind of social search process is what I think has really been studied quite a bit in the network literature when we've been talking about search, is how do we use our context to find different kinds of information. But oftentimes, especially if we're trying to reach far outside our communities, that kind of social search might not be the most helpful thing, right? Because the people that we connect to are going to have relatively similar knowledge to us in many cases. So what you might start doing if you can't type a keyword in and you can't find anyone within your immediate set of contexts that that could give you some input on this, is start browsing through things, right? You might look through, like I said before, your library website or on your university's homepage to see, is there someone else at your university, or is there some kind of keyword that you can find that seems to be associated with the problem that you're looking for. Go to your professional association and look at the sections or divisions and see if there's anything there that might sound like it's somehow related to your problem. And if you do that and you use those categories that, again, pop up in lots of different places to find some kind of solution, maybe you'll connect with a piece of information that will lead you to a person, someone who wrote a report or something like that. And if you do, then you're going to hop outside. You're going to kind of bridge. Most likely, you'll be bridging outside of your area of expertise, right? So my focus then in this project is really trying to understand category systems, right, and how they relate to our patterns of information sharing, and what features of category systems might make them more searchable, might make it easier for people to reach outside their immediate area and exchange information with people who are further off in their knowledge communities. So I'm really trying to map out these conceptual spaces and try to understand what are the important features and what are the properties that might make them more searchable than others. And that's what my hypotheses are going to be about, are understanding the properties of these conceptual spaces. So my first hypothesis then is about the size. One of the most basic features of any kind of set of categories is how many categories do you have available, right? And so on the one hand, if you imagine a system with very few categories and kind of holding constant the amount of content underneath, you're probably going to lump together too many related things, or too many unrelated things. And so if you select a category, you're going to have to do a lot of sifting and sorting and weed through irrelevant information. And it's not going to seem useful to you. If you're trying to find something outside your area, you don't want to sift and sort through lots of stuff that's not relevant, and you're going to just give up and go look somewhere else. At the same time, if you imagine a highly differentiated category system where there are lots and lots of categories, we know from work on behavioral economics and categorization in markets and other areas that people run into these cognitive limitations, right? And they're sifting and sorting through things, not uncategorized content, but now the categories themselves, which is going to make it more likely that they'll give up and just say, this is too much effort, too much work. And so my first hypothesis is fairly straightforward. But it's the idea that the number of categories, the size of the system, what I'm calling the cardinality, should have an inverted relationship, an inverted U-shaped curvilinear relationship with the incidence of bridging. Okay? So those are sort of the aggregate kind of compositional sort of properties of the system. But beyond just those size sort of effects, it's also likely that the complexity of the set of categories is going to play a big part in how people navigate any system of categories. And by complexity, I mean the interconnectedness. So it depends a lot on the system of categories that you're talking about, but there are a lot of reasons why different categories could become associated with one another, right? So think back to, Wikipedia has pages that are categorized into different areas, and each page sometimes has multiple different categories, right? So it's going to be a related set of categories. Or you think about interdisciplinary centers with people who have expertise in multiple different areas, kind of bring categories together. And the more interconnected the categories are, on the one hand, the easier it might be to connect with other areas, because you get more exposure to a more diverse set of categories. And through serendipity or other sorts of reasons, just chance, you might end up running into something that you might start following a set of categories or a pathway that leads you outside your area and brings you to some kind of relevant sort of knowledge. But just like with too much differentiation in your category system in terms of the number of categories you have, kind of holding other things constant, the more complex your set of categories, the more interconnected they are, the harder it's probably going to be for you. Beyond a certain point, it's just going to become harder to navigate. You're going to have to make so many decisions as these categories are branching. Which one do you follow? And then if that's a dead end, you go back. And the amount of information that you're going to have to keep track of is probably just going to be overwhelming and make it more likely that you'll just kind of give up. And there's some work that supports this kind of idea. So hypothesis 2 then is also kind of a more straightforward hypothesis, but is predicting this curvilinear effect of complexity. But the complexity or interconnectedness, as it increases up to a point, we'll see more bridging, but then beyond that point, it's just going to become too hard for people to use. Okay, so one of the things that's important to keep in mind when you're thinking about categories is that they're not, even though they're knowledge categories that are mapping onto knowledge, they're not the knowledge that people use. They're just a representation, right? They're sort of an artificial kind of thing that it doesn't necessarily, it could map more or less onto the actual knowledge that people use. And so the way that I try to capture this idea is by introducing a term I just call informal knowledge domains. And I define that as a group of related knowledge and ideas that emerge in your practice, right? So it might sound kind of abstract, but what I have in mind is just anything, think back to the last time you wrote a paper, right? You probably had a pile of papers on your desk and you're writing things. Maybe you had some statistics books and you had some journal articles written by people from lots of different areas covering lots of different topics. And if you wanted to write your paper, you had to bring all that stuff together and in order to write your paper. And we do that all the time, and all of us are bringing together those different kinds of knowledge. And so that represents some kind of informal knowledge domain. It might not be it may be represented in some kind of category system, it might not. But it's knowledge that emerges through our practice. So this is going to be a key part of the paper, and just to make it a little bit more concrete, let me give you one more example from my own experience. So a couple years ago when I was still in grad school, I was at the University of Michigan. And through this project and other things, I became really interested in big data, which is something we've seen in some of the projects even here already. But the basic idea is sort of big data is like kind of a trendy term, and I think gets used to apply to too many things that it sort of loses its meaning. But the idea is basically, can we take new administrative and other sorts of data sets that are becoming available and use them to answer old, long-standing questions in our research fields in new ways, or to open up new kinds of questions. And so what I was interested in doing, where I come into this, is, well, before I get into that, let me just say, if you want to do a study in this area, if you want to try to use big data, you need a couple different kinds of knowledge that you wouldn't necessarily normally bring together. So you need some knowledge of computation and algorithms to process all the data. Given the size and the complexity of all these data sets, you often need some deep substantive knowledge. Like, so other projects I've been working on are with Medicare claims. And so I've worked with physicians because from someone coming from the outside, it's just so complex to actually know what's happening. And then given that many of these data sets are actually generated by people, you need some kind of knowledge of how people behave in psychology and sociology and human social behavior. So getting back to where I come in then, as I was trying to figure out how to make sense of data sets and learn coding and other sorts of things, I became involved with founding a big data users group for PhD students at Michigan. And it was because there were a lot of people who were interested in this, but what was tricky is it took us a while to get off the ground because we didn't really know who might be interested, right? I was coming from sociology and I had a lot of contacts with people at the business school, and so those were easy people to find, but we didn't expect some of the people we found, like folks from Arabic languages and literatures who were using topic models to study old kinds of documents, or architecture. People are using RFID tags and collecting lots and lots of data. And so lots of places that we didn't end up expecting. And I think one of the reasons it was hard for us to identify all those individuals is because there's no category. You think of all the systems that a university has, and Michigan has them just like everybody else. There's no category for big data that would let us, say, go to a place where we knew that we could find people who were interested in that. And that's in some sense what we were trying to create, was a new category with this group. But it wasn't there yet, right? So what my third hypothesis then tries to look at this idea. And what I'm suggesting is that the degree of correspondence between the set of categories in a knowledge community and these informal knowledge domains can change over time. It can be variable within a community and either increase or decrease. And that as the gap between these categories and the domains becomes more and more narrow, so there's a tighter correspondence, it should be easier for people to connect with individuals outside their domain, and then for bridging to go up, right? And so that's my last hypothesis for this paper is that as we see higher congruity between the informal domains and the knowledge categories, we should see bridging go up. I'm going to skip that for now. So my research setting is Stack Exchange, which is, I'm sure many of you are familiar with. It's a family of online technical Q&A sites. One of the things that's really nice about this is that, so as far as knowledge communities go, and if you kind of buy the definition that I'm using, I'm trying to use this broad definition, anything from science to medicine, you know, it's a pretty, these are simplified knowledge communities, right? They're almost like a mini laboratory. So we know a lot about how people exchange information in this setting. There's only a certain amount of ways that you can exchange information. And we have lots and lots of data that we just could not get in other types of settings, right? So we have complete histories of information sharing and just an amazing amount of data over time. Another thing that makes these really nice is that each one of these sites, each one of these knowledge communities runs on a common software platform, right? And that's really nice because we don't have to worry then about how differences in layouts or other sorts of things might influence the way that people are sharing information. There are differences across the sites, so some of them might be things like the colors and the graphics and things like that, but the basics are identical, right? And so that makes this really nice from kind of a statistical point of view. One of the things I'll talk about in just a minute and that is also really attractive when we start to think about modeling and data is that even though they run on the same software platform, you can really think about these as kind of distinctive and independent knowledge communities, especially for the period of time that I'm looking at. And there are also some incentives for participating. So as you answer questions, and even as you ask questions, good questions, you can build a reputation on the site. All right, so there's some incentives for giving quality responses, and there are incentives for not giving poor quality responses because you can really end up harming your reputation. So here's an example of one of the exchanges that are going to be at the basis of my data. So here's, they're pretty straightforward. So we have questions, and this person asks a little bit about something with a Python programming language. And here's where you see the knowledge categories coming in. So this question's been tagged as Python. And then this person came along, Alex Martelli, who's a guy who's kind of famous in the Python community and written a number of books and things. And he says, yes, answers the question. And then the comments are where people will often kind of add additional information or hash things out. And sometimes they can get testy. Like, so this guy is known as being kind of a stickler for how people make references and the way they answer questions. And so he voted this guy down because he didn't provide documentation. This guy came to his defense and is like, dude, that's Alex Martelli. He's author of Python in a nutshell. He doesn't need to provide a reference. And so there's some back and forth, right? But there's different kinds of knowledge exchange in these different sorts of, in different settings, but it's a limited set of ways that people are sharing information. So here are the sites that I use, the sites that I use and have in my data. So Stack Exchange has really, it's become a really successful platform. And even just over the past couple of years, they've added a whole lot of additional sites. My data stopped in 2012. And at that point in time, most of the sites still focused primarily on science and technology topics. There were a few, like some on the English language and things like that. I excluded those. So I'm just looking at the science and technology. I wanted to focus mostly on fields where the questions would have a right answer. It would be less subjective and make them a little bit more comparable. So I have these 25 sites, and the topics range from things like Android and Android programming to Apple. A couple in the science category are things like physics, statistics. Probably the most famous site is Stack Overflow, which deals with programming questions. and so forth. But you see that they're, again, for my purposes, I'm treating them as different sites because they've been founded at different points in time. They have unique URLs, right? So it's not like you go to one page and then click in the forum that deals with, statistics. They're complete. You don't need to interact with any of the other pages if you don't want to. They all have different numbers of tags. They have different knowledge category systems and then different numbers of members. And although they've done some things to kind of integrate like user accounts across the sites and things like that, at the time I was doing this, it was still independent. You had to register on the sites separately. So when I get the data, they're in a format that's great if what you want to do is host one of these sites, but not if you want to run some data analysis. So they come in a massive database dump that is actually, it's a really nice data source. Some of you may have used it, but you can download the whole thing. It's available through a Creative Commons license and just a massive amount of really rich data. So what I did to kind of get these into shape in a way that I could analyze is I started by pulling out all the posts. So that's questions, answers, and comments using a moving window and created some dyadic exchanges, right? So if I have a question and someone gives an answer, then it represents a dyadic exchange. And I used a 7-day moving window. And I used that a little bit based on some precedents in prior literature. I spent a lot of time looking at the distributions of reply times. Like, so when does a question over what period does it get most of its replies? And if it's not active after 7 days, the probability of it getting any more activity is really, really low. And then the final factor that I'll talk about in a little bit is that there are real cyclical patterns in the way that people use the internet, right? So these sites in particular, a lot of people will use like during the day while they're at work. So weekdays, holidays, you see them less and so forth. And what's nice is that if we use a 7-day window, we have each day of the week represented exactly once, as opposed to say a 10-day window when you could have 2 weekends in there and so forth. So after I pull out these dyadic exchanges, then over this 7-day window, I aggregate these up to try to get an approximation of what does this exchange network look like over a 7-day moving period for each site separately. Once I have that, though, this network of exchanges, dyadic exchanges, then aggregated up, I then run a subgroup detection algorithm, so community detection algorithm, to try to break the network into subgroups just based only on the pattern of exchanges. So I don't know anything yet about what is the content of the post, what are the tags, just looking at the patterns of exchanges. And then the way that I will compute my dependent variable is that then I look 1 day into the future and I identify exchanges that occurred across communities, right? So, I'm in community A and I answered someone's question in community B. That's a bridge in my definition. But if I answer someone's question in my own community, that's not a bridge. So that's how I define the dependent variable. And then I run this process for each site-by-day combination, which is my unit of analysis. And so I have about 18,534 cases, observations then. And this is what one of them looks like. So this is Stack Overflow on August 1st, 2009, when the site was still relatively small, although just visualizing this network was quite a challenge. And I'll show you why in just a minute. So this is at the community level. And again, all we know now is the pattern of exchanges. And what's neat is I spent a lot of time trying to validate these, and I won't go into all the details, but so doing things like pulling up the communities and seeing what do people talk about in these, what are the people that are in these, each one of these bubbles talk about, and is there some level of coherence? And so I ran a lot of analyses to try to see, are they coherent and so forth. And I did find that, so you could really add labels to these that would make sense. Like the central communities in the center typically deal with really popular programming languages. So things like, I think this one's mostly Java programmers. The most popular programming language on the site is C#, which is a Microsoft language. And so one of the languages in the center is C#, C++, other things. Out here you have more on the margins, either smaller kind of specialized programming languages or like big packages or libraries for some of the more prominent languages. So here is just to show you, this is at the community level, you can zoom in, and this is what at the individual level would look like among, these are the Java programmers. And then this is what, as I mentioned before, my dependent variable looks like. Bridges are the new edges that occur across communities. Okay, so that's sort of how I form these networks and map these out. And these are the steps I took to compute the main variables. And the important thing to keep in mind is that to test these hypotheses, what I'm basically doing is trying to look at the relationship between three different kinds of systems that are conceptually and then empirically measured in very different ways, right? So one of them is the exchange network, just who answers whose questions and who comments on whose posts. The other is the tags. So those are what kinds of labels are put on different posts. And then the final is the knowledge domains, the informal knowledge domains. So these groups of knowledge that are topics is another way you could think about that people actually talk about. And so I'll talk about that in just a minute. So the dependent variable I've already talked about is bridging. Cardinality is the size of the category system. And so for that, what I do is just count the number of tags that are available for someone to use on a site at a given point in time. And that changes because tags can be deleted by, say, moderators, or tags that aren't used will be automatically deleted by the system, and people can, under some circumstances, add new tags. So it's a variable that changes over time. For complexity, this is just basically like the tag co-occurrence network. So if two tags appear on the same post, then I record a relationship between them, and I weight the number of times, the number of posts that they end up appearing on together. And so my complexity is just basically a measure of the average path distance between tags in the tag network for a given site at a given point in time. So those are straightforward. What's a little less straightforward is how I would measure this idea of an informal knowledge domain, right? Because kind of by definition, these are things that might not necessarily be recorded officially on a site or anywhere in a knowledge community. And so the way I get at this is, again, by leveraging one of the cool features of this setting. And that is that we have all the text for all the posts over the history of a site, right? So what I start doing is, again, using a moving window type approach, for each site and each day, I pull out and make these big post by term matrices, right? So for each post, I know what words were used and what was the frequency with which those words were used. And then I do a number of different weighting, term weighting, and term frequency weights to kind of account for words that are commonly used and so forth. Now, once I have these big matrices, I can then start looking at the similarity of posts based on their text content. And after I create these similarity matrices, I then use a bottom-up clustering algorithm. It's known as affinity propagation to put these posts into discrete bins, right, into discrete clusters based on their similarity. All right? And what's nice about affinity propagation is that it's actually really, really fast for even massive data sets, lots and lots of observations. And unlike some other clustering algorithms like topic models or k-means, things like that, you don't need to specify in advance how many clusters you think you're going to find. It just induces the number of clusters from the data, which is really, really nice, especially for my purposes, because there's no way I can go through each site and each day combination for 18,000 of these and have any kind of knowledge of how many topics essentially I would expect to find. So then once I have that, I compute my measure of congruity by using this. So this is a measure from information theory. It's known as mutual information. And sometimes it's used in like computer science and statistics to look at the quality of a clustering algorithm as like a fit measure. But I'm using it in more of a substantive way. So it's sort of like a measure of correlation, but you can use it for discrete variables, and it's good for nonlinear relationships. So I have two ways at this point of categorizing each post. I have the tags that have been applied to that, and I have the cluster, the knowledge domain. And then when I use this measure, I can then, as I said, it's sort of like a measure of correlation. And the way you can interpret it is, one way you can interpret it is as how much is your uncertainty about one random variable reduced after you know the other variable, right? So in this case, you could think about it as if you know the text of a post or you know what domain it's in, could you anticipate the tags? Or if you know the tags, could you anticipate what the post is going to be about? And on sites that have really low values on this measure, the tags aren't going to be very informative, right? It's like the big data example. We can't find people who are interested in big data because they don't really map well onto the domains of what people are using. And by contrast, in the, if the values are higher, it's going to give you more information about the tags are going to be more informative. All right, so I've gone over a number of these so far, but this is how I then ended up estimating the statistical models. So I have 25 sites, daily observations from August '08 to July 2012. I'm using fixed effects panel models. So these are really, really long panels. I have not that many observations, not that many sites, and lots of time periods. So I use these Driscoll-Cray standard errors that are corrected for those long time periods. The dependent variable is bridging ties at time t+1. And then I have the deep independent variables I've talked about, the quadratic terms. And I have a lot of different controls. So I have things like behavioral controls to try to get the things like the level of homophily. The level of homophily in the way that people exchange information. I have a couple different measures of that. I try to account a little bit for how people tend to be evaluated. This is a community where people are really likely to vote your question down. Is this more of a hostile community or a friendly, welcoming community? A lot of different controls for network structure, some organizational controls. I can talk about these in more detail if you have some questions. So these are the results. I have some better ways to present these, but just a couple of controls, that show you, a little bit. Things seem to make sense. So here, like the measures of homophily are really consistently negative, and so the more that people tend to connect with other people who have similar interests, which is defined differently from the network measures. The less bridging we see, and so a number of the controls end up making sense. So looking at the first hypothesis was on cardinality. So the more tags you have, the better, up to a point beyond which it's just going to get too confusing, too complex. And I find some support for that. So here is the predicted values. This is the predicted change from adding 200 tags, holding other factors constant. If you're at the 10th percentile with respect to the size of your category system, and you add 200 tags, you would expect a 48% increase in bridging, the incidence of bridging. Then if you're at the 90th percentile and you add 200 tags, it's a much smaller but still positive, about 2.8% increase in bridging. So I don't quite see the negative effect. I do end up seeing it within the observed range of the data, but it's only at pretty extreme values. If you drop Stack Overflow, which is different from the other sites in that it's much like an order of magnitude bigger, it's older, more famous, then you do start to see this negative effect in more of the meaningful ranges of the data. I also find support for the complexity hypothesis. So at low levels of complexity, increasing the complexity by a standard deviation leads to about 20% increase in bridging, or at least is associated with that. Whereas if you're at the 90th percentile, adding complexity is associated with a decrease in bridging. And then this is what I find for the a congruity hypothesis is also support. So a 1 unit increase in my measure of congruity, and I put this on a 100-point scale, is associated with something like a 2.4% increase in the incidence of bridging. So I ran a number of robustness checks. So one of the things I did was drop Stack Overflow, and I find support there. Look at the outcome over a longer period of time into the future, and I find some support there. I've also looked at a number of different ways of measuring the outcome, bridging. So one concern is maybe the network, maybe the outcome is a little dependent on the community detection algorithm and things like that. So I've also looked at a couple other measures that look at just the path distance between people who are connecting, and is that associated with longer path distances. I've also, some questions about changes in topic areas, and what if these are rapidly developing technology areas. And so I looked at just the sites that dealt with more of the scientific topics that are usually dealing with established kinds of questions, like physics and so forth, and I found similar results. Did a couple instrumental variables that I could talk about. And I also spent a lot of time, so one thing that I've heard people have questions on, I have myself had questions on, is don't a lot of people find questions on Stack Overflow using Google, right? And you type them in and they get that. Well, one thing about that is that that does happen, but it's not generally the kinds of questions that are going to come up in this database, right? So Google indexes the Stack Overflow sites, but most of the questions on Stack Overflow end up getting Stack Overflow and the other Stack Exchange sites usually end up getting answered within a day or so, right? And so unless you type in like the exact title of the question into Google, you're never going to find it. It's never going to come up that high in the search histories until like months later after it's got many replies and so forth. And so I don't really think that's a big factor driving these analysis. But I also looked at a much earlier subsample. So just a little bit, 2008 and part of 2009, which is when Google was updating its index on a much less regular basis. And then I still found some good results there. So the motivation for this, as I said before, was trying to understand these perennial calls across lots of communities for deeper integration, right? Why do we keep hearing about all these silos and companies that prevented us from having the next great breakthrough? Why are provosts always saying we need more interdisciplinary work when another part of our literature seems to suggest that there are a whole lot of benefits from connecting across these groups? Why don't they just close, right? And so there are a number of different reasons you can pull out of existing work. But I think one thing we haven't focused on quite as much yet are differences across the communities themselves. And are some factors likely to make some communities more searchable than others and more likely to close, including things like the way that knowledge is organized. Are some kinds of concepts more perceptible to people and allow them to more easily connect outside their own area? And so that's the area, that's what I've been trying to get at with this paper. So thank you.
Thank you.
So when you look at these bridges that have formed, you are essentially looking at the success stories.
Mm-hmm.
You're looking at the bridges that have been established in a successful manner. You can see it in that data, but there are also lots of failures in which they did not succeed.
Mm-hmm.
So you are essentially looking at a biased sample in which these bridges have been formed and they're effective. But overall, there would have been lots more attempts that have been actually made, and they just did not get the traction. And
mm-hmm. Could be, I mean, so to some degree, yes, but so in the sense that I don't capture the case. I don't capture cases where someone wanted to bridge but couldn't find a way, right? But in terms of, you said effective, there are lots and lots of bridges in this case that are complete disasters, right? So there are some that ended up working out well and they helped answer someone's question, but there are others where, and probably the majority of them, so I don't look at the quality at all in this. These are all bridges, some are good, some are bad. But in many cases, people will answer a question and they'll be like, I don't even know what you're talking about. So someone has a question in like Python and they're like, well, I don't know, but in like Fortran, you might do it like this. And they're like, well, I'm not programming in Fortran. Why are you telling me about Fortran? Vote down, And, or someone just completely misunderstands the question. And so there are many disasters that happen in this too. Another factor that kind of helps to mitigate against that to some degree is that, so I have not only the posts, the answers, which require a little more energy, but also comments too, where people will often give some tidbit that might not answer the question but pushes you in the right direction. And I mean, the level of effort it necessarily requires to add one of those is pretty low. But so I think relative to some places, the costs are not especially great, and there is huge variation in quality. But yeah, so just definitely like anything, there's probably some success bias here.
Yeah. Thank you for the nice presentation. I really like your idea, the relationship between the bridging time and the cardinality or complexity of the categories. But I'm not very convinced that relationships are, nonlinear, because I believe each time point you identify or define the subgroups, probably using some community detection algorithm. So let's say an early stage of the time period, you identify 2 subgroups, and there must be few bridging times. But as you hypothesized, the number of bridging times increasing, then the community detection algorithm will consider these 2 distinctive subgroups as a one subgroup. then the number of bridging ties suddenly drop.
Yeah, so no, definitely. I mean, that's been a concern that I've had too. The reason I did the community approach is that I think it just, I mean, from the diagrams, hopefully you guys saw that. Like when I look at them, it just looks so intuitive, right? When I think about bridging myself, or I think about going to work with someone in another part of my university, like that's kind of what I picture in my head. Different communities connecting across them, and so that's one of the reasons I did that, was because I think it's easy for people to wrap their head around, and it has some substantive basis. But I've also checked this in a lot of different ways, right? So one of the models I have up there, I looked at people's interests. So I looked at areas that people had posted in the past and the kind of things that they had talked about, and tried to use basically like a textual approach to see how similar or different were two people that ended up exchanging. And if you were a certain number of standard deviations away from each other, you just talked about very different things, and all of a sudden you then started talking about something similar, then you'd find that as a bridge. And I also looked at something that was just based on path distance, right? So set aside all the communities, but if I'm in one part of the network and it takes me 5 links, there are 5 links separating me from someone else, then if above a certain threshold, you can say that it's a bridge. And so I've looked at some of those other factors too. So I think that's what I've been doing, is saying, kind of there's a trade-off in that, intuitively, maybe the bridging, the communities is easier to understand, but it has some of those other troubles. So my approach to dealing with that has been to try these different robustness checks.
Yeah, so following up exactly on Poon's question though, so it seems like more fundamentally the issue is that communities are defined, or your community and the notion of a bridge as a result are defined endogenously as a function of the network itself. So you might have a lot of let's say you define your communities as connected components, then you would never find bridges, because by definition there are no bridges between different connected components. So you have textual data available. So what's wrong with using the textual data to define the communities exogenously of the network, and then using those to see how many bridges you have?
Well, I mean, what I'm most interested in this case, and my independent variables are all the non-network factors, right? They're the informal knowledge domains and the tags. And so, I thought in that sense that just having the network is all on my, my left-hand side, and that was, helping me to get over some of the precisely the issues that you're raising. So I guess I thought of that as being an advantage. But I think that well, like I said, this robustness check that I've done, looking at the similarity of people, which corresponds to this model 3, is basically what you're talking about, looking at the similarity of people based on using the textual data. And if these people are very dissimilar using, say, a cosine measure, then we can say, beyond some, there you have to identify a threshold too. Same thing with a path distance measure, which you don't need to do with the community approach, so which is another reason why I did that. But yeah, so.
Looking at your model 6, is that for addressing some of the potential that may be caused by, because you have the IV was t-1, is it?
The DV was t plus 1.
The DV was t plus
Yeah,
1,
t plus
IV
1.
was t.
Yeah,
So it's
yeah.
lagged.
Yeah.
But I was wondering if, for example, your complexity can be driven by the bridging in the previous, and then you get into this somewhat simultaneous, but lagging does not completely address that problem.
Maybe it's possible to some degree. So that instrumental variable is not really designed to get that. The tags, though, the complexity and the bridging are just two separate networks, right? So the complexity is based on the co-occurrence of tags, right? So do the two tags, does Python co-occur a lot with MySQL or R? Whereas the outcome, the bridging, is based on these exchange patterns alone. So they're like different sorts of things, different systems. It's possible. Maybe you could tell me more on how you're thinking that the complexity or the bridging is going to drive complexity. But the one advantage is that they're just two different sets of data.
If you run the bridging, wouldn't that post would have been tracked by both sides?
No, no. So the tags, like I said, are totally different. I mean, so if I, I might be someone who just talks a lot about Java, and I post with other people who, are interested in Java sort of things, and I'm in one part of the network, right? And then someone suddenly tags, writes a question, and they tag it with Python, right? There's nothing, nothing has to do with Java or anything like that, but I can still go and bridge there, and there's not going to be, it won't necessarily have a Java tag or anything like that to go with it. Yeah. Yes.
So, I mean, I think what some of these questions is because I think you clarified that while you're dealing with the actual post network, everything on the explanatory variable is text-based.
Exactly.
Right? It's all tag-based.
Yes.
So one of the ways, that I can see why you would do that as a clean distinction. But one of the ways to address this issue about, to what extent is your definition of a bridging tie an artifact of the algorithm that you're using. That's part of what I'm hearing in community detection. So, and that is, I can see that as a problem. One potential way in which you could solve that problem, which actually you benefit from one of the criticisms of these community detection techniques, is that in community detection techniques, you essentially have a dial, and you can choose at what level of specificity to get these communities, right? These separate communities to show up.
Yep.
So one way that you could actually use that to your advantage here is to try it with different cutoffs, essentially, and see if your results are robust across various cutoffs. So that even if you set it up so that you have 6 communities or 300 communities,
Yeah.
and then look for bridging ties as in each of those particular cases. I'm not saying that many, but if you could demonstrate that it is in fact robust to the specific tuning parameter that you use, then I think that might actually fend off some of the criticism.
Yeah, that's a good idea. So like cutting the dendrogram at different places.
Yeah, exactly.
Yeah, yeah. No, that's a good idea. Yeah, I'll have to. That should be easy to do. I like that. Yes.
Okay, thank you very much.
Well, thank you very much.